Greetings everyone. I believe you are well. Welcome to my YouTube channel for Kangaroo Maths and Science Academy. Ladies and gentlemen, I want to take you through mathematics paper 1 for hyperbola and straight line. I had created a video for hyperbola, but couldn't manage to finish it due to time. But now I want to take it forward in order, or like so that we can be able to answer the question. Kindly, I'll not just go through the basics of hyperbola. I have explained the steps of sketching hyperbola. Kindly go through the first video in order to follow with me. Don't forget to like, subscribe, and hit the bell button for future video notification. Right, without wasting time, let's now dive into the tutorial. Right, we are given the first equation. I think I've addressed it in the first video, but I just want to elaborate some of the things that are important here. Number one, we are given the function. Okay, let me just try to minimize this. This time around, I wanted to use the, okay, let me take it vertical. Okay, let me just say more. The names. Okay, just a minute. Okay. Actually, I wanted to use this. Okay, let me just take it at the bottom. Right, I want to use a pen now. I want to use this option for a pen. Okay, right. On this question, we are actually given f of x. So the f of x is actually equals to 2 over x minus 1. This is actually a hyperbola. So we're given a hyperbola. And also a given g of x, which is x minus 1. Obviously, this is a straight line. So we're given a hyperbola and a straight line. Right, let us now go through the first question. The first question says, write down the equations of the asymptote of f. We know that f has, the hyperbola has two asymptotes. It has the horizontal asymptote and the vertical asymptote. The vertical asymptote has to do with x. It means this will be x equals to 1, and the horizontal asymptote will be y equals to 1. So these are the asymptote of the hyperbola. So we've answered the first question. Now, in the second question, it says, determine the x-coordinate of the x-intercept of f. And we know that since this is a hyperbola, okay, guys, as I was saying, I was talking about the domain and the range of the function. Okay, let me just set this. Okay. Okay. Yeah, okay. So I was talking about like how to determine the x-intercept. The y-intercept will let y to be 0, equal to 0 and minus 1. The domain of f, we just restricted x not equals to 1 as an asymptote. Now we want the range. How to determine the range? In order to determine the range, it means now we need to first say this. We will say the range is y is an element of real number, but y should not be equals to the horizontal asymptote, which is just 1. So we only restrict the vertical and the horizontal asymptote when we are determining the range of a hyperbola. Right, moving on, the next question, it says, determine the equation of the line of symmetry that has a negative gradient. We know that we have line of symmetry has two, I'm saying hyperbola has two lines of symmetry. So here it's just a type. We're supposed to say determine the equation of the line of symmetry of F that has a negative gradient. So the equation is y equals to minus x plus c. And in order to determine the value of C, we need to use asymptotes. We have to use asymptote. And what is our asymptote? As our asymptote, it's x equals to 1 and y equals to 1. So it means here where there is x, we're going to substitute by 1. So we're going to have 1 equals to, so where there is y by 1 and where there is x by 1, but this will be negative 1 plus c. And which means the value of c, if we transpose 1 to the left-hand side, it will give us 2. So which means that the equation of the line of symmetry that has a negative gradient of f, it's minus x plus 2. So we got the answer. Right, moving on to 1.6, it says if h of x equals to f of x plus 3 minus 1, describe the transformation of h from f. It means we have to describe what will happen from the equation of f, which is the hyperbola, to h. Obviously, this graph is going to shift. The graph will shift 3 units. The graph will shift 3 units to the left and 1 unit downwards. One unit downwards. So this is what is going to happen. So the graph will shift 3 units to the left and 1 unit downwards. The left, because this plus 3 is affecting the x, and the negative 1 is actually affecting the y. Actually, the plus 3 is affecting the x, but particularly the p. So the graph will shift 3 units to the left and 1 unit downwards. So the next question says, now determine hence determine the domain and the range of h. So we want to know what is the domain and actually the range of h. And how do we determine the domain, the range of h? We cannot determine the domain, the range of h without having to get the equation of h. Remember, h was f of x plus 3 minus 1, where the equation shifted how many units? 3 units to the left and 1 unit downward. So it means we can now determine the equation of h. And to do that means we are going to transform the equation of f. What is the equation of f? Is 2 over x minus 1 plus 1. So here we are going to shift the graph of f 3 units to the left. So the left means on the x we have to add by 3 to be to the left. And now on the q we have to reduce by 1, which is downwards. So which means the equation of h now will be 2 divided by x minus 1 plus 3, it's plus 2, and then plus 0. This will now be 0. So what does this mean? It means the asymptote now of h, it will be x equals to negative 2 and y equals to 0. So it means for q it's 0. So in terms of the domain, we'll say the domain of h would be x is an element of real number, but x should not be equals to negative 2. Then same applies with the range. Is y is an element of real number such that y should not be equals to 0. So this is what we this is what we're supposed to do. We have to find the equation of h by transforming f. I believe you're following. Then 1.9 says, write down the equation of w resulted after reflecting f. It's a reflection of f about the x-axis and thereafter a shift of 3 units downwards. So we know that when we are reflecting a graph, for the first one, we need to do a reflection. According to the statement, we know reflection about the x-axis means x will not change. What is to change is the y. So it means if y was positive, then it will now becomes negative. So let's do the transformation. What is the equation of f? The equation of f is y equals to 2 over x minus 1 plus 1. So what does this mean? Reflection about the x-axis means the x will not change. The x will not change. What will change is the y. It means the y becomes negative here. And since we let y to be negative now, it means you have to write the equation in a smart form. And to do that means you have to remove the minus by multiplying both sides by negative. Remember what you do on the left, must also do it on the right. So it means the equation now will be y equals to, now the numerator will be affected, it will be negative 2 over x minus 1, not the denominator. Then also even the q will be affected, so it will now be minus 1 when we multiply by negative. See, now the graph will shift 1 unit downwards. Then again, after this, there must be a shifting. We shift 3 units down. Obvious, 3 units downwards will affect the q. So it means from here, we reduce this by 3 because it's downwards. So the equation now will be negative 2 over x minus 1 minus 4. So which means the equation of wx will be minus 2 divided by x minus 1 minus 4, because this reflection about the x-axis and also a shift of 3 units downwards. I believe you guys are following. Then 1.10 says, hence now determine the coordinates of the x-intercept of W. Obvious, to determine the x-intercept of W, the x-intercept, we need to let y to be 0. And to do this, it means from the equation of W, because W is the y value, we're going to say 0 equals to minus 2 over x minus 1 plus 4. We need to solve for x here. So what we're going to do, we're going to transpose. Okay, I apologize. There's a typo here. I said plus 4 instead of minus 4. Right? 10. Okay, so it's supposed to be negative 4 here. So since it is negative, so we're going to transpose minus 4 to the left-hand side. This will be 4 equals to minus 2 divided by x minus 1. Then since this is a fraction, we divide it by 1, then we cross multiply. We're going to have 4 into x minus 1 equals to negative 2. We remove the brackets. This will be 4x minus 4 equals to negative 2. Now, if we do this, we transpose minus 4 to the right-hand side. It means 4x will be minus 2 plus 4, which is just 2. I'm saying minus 2 plus 4, which is 2 divided by 2. Then the x becomes half. So which means the coordinate of the x-intercept of W is half and 0. I believe you guys are following. Then the second question, like the 1.11 says, on the same set of axes, sketch the graph of f and g. Clearly show the coordinates of the intercept with the and the asymptote. So let's do this. Okay, let me just try to erase this. Okay, I think even the first one, yeah. Okay, so we're gonna have So this will be our graph, I'm sorry, our Cartesian plane. Let's call this the y-axis. Then let me construct the x-axis, although you can see that it's not. Okay, let me just try to. Okay. Okay, then now, okay, let me construct. Okay, good. Right now, this is the x-axis. Okay, okay, right. Pen. I don't want this. Okay. Right. Then now this is the, come on. Okay, we have the, okay, it means I click there. Okay. Now I want the pen. Okay, this is my x-axis. Let's start with the vertical asymptote for F. What is the vertical asymptote for F? It's x equals to 1. Yes, it's x equals to 1. So where is x equals to 1? Okay, fine. I'll just use a, come on. Okay, let me use a red one. Okay, so this will be the vertical asymptote. So this is x equals to 1. And the horizontal one will be y equals to 1. So this would be y equals to 1. Then what is the x-intercept? The x-intercept for F, we got, if I'm not mistaken, we got -1 and 0. Yes, -1 and 0 is the x-intercept. And the y-intercept is 0 and -1. Okay, so it means it's -1 and 0. Right, with the x-intercepts, the -1 and 0, we can just say it somewhere here. So this will be -1 and 0. And the y-intercept, this will be 0 and -1. So which means the graph must pass here. We know that when we are drawing a hyperbola, the graph must move parallel to the asymptote. So drawing the graph that has to move parallel to the asymptote, it means the graph will look like this. Okay, let me just use the graph must move parallel to the asymptote, parallel to the asymptote. So it means it must have something like this. It must pass through, and yet it must move parallel to the asymptote, parallel to the asymptote. So this is the graph of F. But still we know that if it's this side, so it means due to this line of symmetry here, it means we need to have another one this side because of the shape. So the other part will be this side. Should be parallel to the asymptote. So this is the graph of the hyperbola, parallel to the asymptote. Okay, this is our asymptote. So this is the graph. But remember they said we need to draw the graph of F and also for G. G is a straight line. And what is the equation of a straight line? The straight line is given as G of X, it's X minus 1. Obviously, with the straight line, we just get the x-intercept and the y-intercept. And we know with the x-intercept, we let x to be 0, y to be 0, So solving for this means x will be 1. So it means as a coordinate, the straight line will pass through 1 and 0. And in terms of the y-intercept, because this is the y, we have to let x to be 0. It means it will be 0 and minus 1. So it means the graph will pass through 1 and 0. 1 and 0, it's here. Because this is the exhaust, is the vertical asymptote. So it's 1 and 0, it's here. And minus 1 and 0 would be here. So it means this is it's where the graph must pass through. So let's try to let me use a different color. Okay, no. I think, what is this? Okay, fine. So we're gonna draw a line that exactly pass through. Okay, let me change this. Okay, let me just use, let me just use a black color. Blue, okay, let me just use blue. So it means this graph has to pass through. It has to pass through, okay, can I make it? Okay, let me increase the thickness. Okay. Okay, let me try this one. Yeah, I think this would be fine. Okay, let me just try to reverse this. Okay, sorry. Yes, okay, then now it means the graph will pass through this point. The graph will pass through the point, even there, up until it touches the other part. So this is our line. So this is the G graph. Okay? Right, you can easily see that the two graphs are intersecting at 2 points. You can easily see that the two graphs are actually intersecting at 2 points. They're intersecting at this point here and also at that point there. So let's call this G. Let's call this one the G and this one is the F. Okay, so we have sketched the graph for F and G on the same set of axes, and all the intercept are shown with the asymptotes. So now we can now move on to the next question. Right, in the next question, it says, determine the coordinates of the point of intersection of F and G. So actually, we want to know the coordinates of the point where the two graphs are actually equal. Obvious, these two graphs are equal at 0 and -1, and even this point. So we actually wanted to know the coordinate of this point. So to do that, we're going to take both the equation of F and G and we equate them. So we're going to say at the point of intersection, it's where f of x equals to g of x. And what is our f of x? It's 2 over x minus 1 plus 1 equals to x minus 1. Remember, the main ways to skin a cat. We have to simplify fraction here. We can first transpose the plus 1 to the right-hand side. This will be x minus 1 minus 1, which is minus 2. I believe you're following, but since this is a fraction, we can divide it by 1 and cross multiply. We're going to have x minus 1 together with x minus 2. This equals to 2. Then we remove brackets. So it's x squared minus 2x minus x is minus 3x. Then plus 2, then we transpose 2 to the left-hand side. We equate this to 0. So this will give us x squared minus 3x equals to 0. Then we take common factor because we have 2 times it's x. So we're going to remain with x minus 2 equals to 0. Then we solve for x. Solving for x, this will give us x equals to 0 or x equals to 3. But by the way, we want to know the coordinates. So we're going to say we choose any between g and f. Let's just use g and say, since we have y equals to x minus 1 is the g. If x is 0, what is the y value? Where there is x, we put 0. 0 minus 1, this will give us a value of negative 1. And when x is 3, where there is x, we substitute by 3. 3 minus 1, this will give us 2. So it means the first coordinate says 0 and negative 1. And the other one is 3 and 2. So already we got the coordinate for both the 2 points. So we can go back and say now, we know the coordinates of the 2 graphs. We know here it's 0 and negative 1, and here we know it's 3. X is, let me just write, it's 3 and 2. So we know these values here. Okay, now we can continue with our question. Then the next question says, use the graph to determine the values of x for which f of x is actually greater than g of x. We need to use the graph to determine the values of x where f of x is greater than g of x. What does this mean, ladies and gentlemen? It means that from our graph, we actually wanted to know what is the value of x, where f is actually bigger than g. So we want the value of x where the f it's actually above or equals to g. Where f is above or equals to g, that's what we want. Where the f is above g. Okay, let's do this. I'll just use, if you look at this point, let's say, let's look at where they equal here. If you look at any value less than 0, this graph of f, this f, it's actually above g. This is the g. So f is above g for any value of x that is less than 0, actually this side. And look, from 0 up until 1, yeah, g is above f, is not what we want. But when you consider from where x equals to 1 up until the point of intersection, yeah, where x equals to 3, f is actually bigger than g, f, but excluding x equals to 1. Because at x equals to 1, the graph of f it does not touch. So it means to explain, to give the answer, we say, we can write this into it. We say, what is the value of x here? The value of x is 0. So we can say any value of x that is less than or equals to 0. Any value of x that is below or equals to 0, we allow it, or any value of x that is from 1 to 3, because between 1 and 3, the f is bigger than g, but we are not including 1. We can include 3 because at 3 are equal, but at 1 we are not including. Why are we not including 1? It's because at 1, the graph of f is not touching, it's an asymptote. And look, let us look at points that is above 3. Points that are above 3, G is bigger than F, so it's not what we want. And you can also get this algebraically without having to read from the graph. You can also use inequalities, but you must be careful when you're dealing with fractions. So it means the answer for the first question, the f of x, where f of x is bigger than g, it would be any number, any value of x. Okay, let me just use. So any value of x, that is less than or equals to 0, or any value of x that is between 1 and 3, excluding 1 but including 3. Another way would be, we can write this as a set notation to say we allow any number that is from negative infinity, because this side, remember, this side is negative infinity. So this side, this side is negative infinity. And this side is positive infinity. So allow any number from negative infinity up until 0. And from 1 up until 3. So we can also write it in that way. So we can say from negative, excluding from negative infinity, because we don't know what is that infinity, up until 0, inclusive, or open brackets, we're not including from 1 up until 3, but including 3. So you can also write it in this way. So we've answered this question. Now let's move on to 1.13.2. It says where f of x times g of x is less than 0. So let's go back to our graph and explain this. So I will erase the 2 because already we have answered the question regarding this. So here we want the value of x where f times g, where f of x, let me write it down, where f of x times g of x is actually less than or equals to 0. And what does this mean? When we say where f of x is less than or equals to 0, it means we want to determine the value of x where either one is positive and the other one is negative, because less than 0 means we're looking for negative values. So it means if we want this to be negative, it means it's either f is positive, and at that time g is negative, because positive times negative will be negative, or f is negative and g is positive. That's what we want. And what does this mean? It means that we want to look from the graph where f is above the x-axis, and at that time g is below the x-axis, and or where f is below the x-axis, and by that time g is above the x-axis. So it means one must be above the axis and the other one must be below, which means another one should be positive, another one should be negative. Right, let's look here from this point up until 0. Okay, let's say up until 1, not necessarily 0. Do you see that the value of f just from negative infinity to exactly 1, just exactly 1, the graph of f is above the x-axis. F is above the x-axis. So if f is above the x, it means this is the point where f is positive. Because it's above the x-axis. And at that point, if we cut at x up until x minus 1, g is below the, actually g is below the x-axis up until 0. It's negative, g is negative. But above 0, g is also negative up until 1. But above 1, g is positive. So we want where one graph is above and the other one is below. And where is this point? So it means you can say just from minus 1, let me not say, yeah, any number less than minus 1, any number less than minus 1, that's where we have where the f is above and the g is below. But just look at between minus 1 and 0. Between minus 1 and 0, f is below the x-axis. Even at that time, g is below the x-axis, so it's not what we want. They're both negative. But from 0 up until 1, still they're both negative. So let's say from minus 1 up until 1, these two graphs are both negative. They're below the x-axis. But they're below the x-axis. So we want where one is above the x-axis and the other one is below the x-axis. So now from our graph, just from minus 1, no, just from 0, I mean to say, to 1, g it's negative and f it's at that time is negative. Then but from 1 up until infinity, both are positive. So it's not what we want. So it means the answer here, it will just say we allow any value that is less than or equals to 0. X should be less than or equals to 0. According to this. So it means the answer here, we can say the answer for this one is x is less than or equals to 0. Or we can say from any number from negative infinity up until 0, inclusive at 0. That is the answer. Unless if I missed something. But I believe I did not miss anything. And we can also confirm this algebraic. So f is above the x-axis, g is below throughout up until 1. This is below, they're both below, both above, so it's not what we want. Okay, let me erase this. Okay. Right. What is the next question? Okay. The next question, it says, okay. Let's use red. Then what is the next question? Let's move on to the next question. Oh, we want to where f of x divided by g of x is greater or equals to 0. Let's write this down. F of x divided by g of x is greater or equals to 0. F of x divided by g of x. We want it to be greater or equals to 0. It means you want this to be positive. Greater or equals to 0 means you want this to be positive. And to be honest, the only way this can be positive is when f is positive. Okay, let me use some color. Okay, let me just use them interchangeably. So it's when this is positive and this one is also positive, or when f is negative and this one is also negative. So it means there must be both positive or both negative, both above, both below. So obvious, what is the answer? The answer is where we did not include from the previous question. So where will we get the answer? Where they are both positive or both negative. So this is the answer. Look, from any value, actually we're gonna say from just from -1 above. From -1, the graph of f is below the x-axis, so it's negative. And the graph of g at that point up until 0, it's also negative. So you see that from -1 up until 1, the graph it's positive. They're both negative. And also from 1 up until infinity, they're also both, but they're above the x-axis. But there's only one thing that we need to restrict, the x equals to 1, because at x equals to 1, the graph of f does not touch. So it will be from -1 up until 1, excluding 1, or from 1 up until infinity. Or we can just say, yeah, but still it will be between -1 and 1, and or any number bigger than 1. It's also fine. Because remember, they're both negative, both positive. So we can just say from -1 to 1, we can just say from -1 up until 1, excluding 1, or any number bigger than 1. Yes. We're actually excluding the 1, or we can say it's from -1 up until infinity, but x should not be equals to 1. You can also do it in that way. Or we can just say, or including from -1, including up until 1, excluding, or from 1, okay? Okay, this one cannot erase because it is that one where we're annotating. Okay, let me erase this. So now, yes, those are the answers there. Okay, actually from -1 straight to 1, but not including 1 to infinity. It's also fine. Then the next question. Then the next one, it says where f of x times g prime x is less or equals to 0. Where f of x times g prime x is less or equals to 0. Okay, before we answer this, let's now first answer 1.13 and we'll come to that one. So in terms of 1.13, this one, what do we want? We want to determine the equation of the inverse of g. And what is the g? The g is y equals to x minus 1. And how do we find the inverse? Remember, it's reflection about the line y equals to x. So we swap the values of x and y. This become x and this become y. And we make y the subject of the formula. So this will be x plus 1 equals to y. So which means the equation of the inverse of g equals to x plus 1. Okay, then 1.14, it says write down the equation of the line of symmetry of the inverse of g, of f. By the way, what is the equation of f? The equation of f is y equals to 2 over x minus 1 plus 1. In reality, guys, with the inverse of the hyperbola, the p and q just swap each other. So it means it will not change. You're just going to have 2 over x. Okay, I think it's going to be, because it's just the inverse of that, x become y, y become x. Still, it will be minus 1 plus 1. Let's confirm that. Remember, reflection about the x, this become x. This becomes y. So we make y the subject. So this will be x minus 2, x minus 1, sorry. Okay, x minus 1. So we're going to have x minus 1 equals to 2 over y minus 1. So let's swap. So this will be x minus 1 multiplied by y minus 1 equals to 2. Since we want to make y the subject, we still divide it by x minus 1. Okay, apologize. So we divide there by x minus 1. So dividing by x minus 1, this will give us so we divide by x minus 1 and here by x minus 1. So we're going to remain with y minus 1 equals to 2 over x minus. Then we transpose minus 1 that side. This will give us the equation of 2 over x minus 1 plus 1. You see, it did not change. So now the equation wants the equation, write down the equations of the lines of symmetry. Obviously, to determine the equation of the line of symmetry, we still need to get the asymptotes of this equation. Already the asymptote will still be x equals to 1 and y equals to 1. And honestly, to determine the equation, let's start with the first one, y equals to x plus c. Let's start with the one of positive gradient. If this is 1 and that one is 1, that is c. So c is 0. So what is the first equation? The first equation is minus x plus 0, which is just minus x. And the second one, already there's no need for me to write because already it's minus x plus 2. So it's two of them. Is this one y equals to minus x, and y equals to minus x plus 2, because already we got this in the first question, like where they say determine the equation of a line that is a negative gradient. Okay, then now this one we want to know the value of x where f of x times g prime of x it's less than 0. Let's go to our graph and try to analyze this. So we want the value of x where f of x times g prime of x it's less than 0. Okay, I want us to answer the question. Okay, this for grade 12. F of x, we want where f of x times g prime of x it's less or equals to 0. We know when we talk about g prime, this is a derivative, and it has to do with the gradient. So we want to where the gradient of g, we're actually dealing with gradient, but since we say less than 0, it means it's either this one is positive. Okay. It's either the f is positive, and at that time the g is negative, because we want less than 0, or f is negative, and at that time g is positive. So what does it mean? It means we want where f is above the x-axis, and at that time the gradient or the line of g it's decreasing, because it's talking about a gradient, or where f is below the x-axis because it's not a gradient. And at that time, the gradient of f is positive, means where the graph is increasing. So it's either the graph of g is increasing because its gradient is positive, and at that time, g is below. So let's do this. Let's first look at the graph of g. The graph of g is actually increasing throughout, from left to right. The graph of g is actually increasing throughout. It's increasing. It means its gradient is positive. So we wanted to know at that time when the gradient is positive, it means we do not, they would not have this information. We want to know the value of x where the graph of the gradient of g is positive. And at that time, f is below. Where is that point? Let's first look where f is below. F is below from -1 to just up until 1, but not including 1. So what will be the answer here? The answer will be where the graph f is below, it's from -1 up until 1, but not including 1. So that's where f is below the x-axis. It's negative. And at that time, when f is negative, the gradient of g, the line g is increasing. So it means the answer will be from -1 from -1. We didn't just use a different, because now it's from -1 inclusive up until 1 exclusive. We're not including 1 because the graph of f does not touch at 1. And by the way, guys, this is you can use another approach. Okay, I just want to rewrite this because it looks like the values are not right. So let me just write the answers here using a pen. So it will be from -1 to be from -1. Come on. It will be from, okay, -1 inclusive up until 1. Right. Then now, okay, I want to raise this. Let me raise this. So from 1 up until -1, that's where we have the answer. But you can still confirm these answers algebraically. So, but you must be careful when you are confirming answers algebraically. For example, let's say we want to confirm the issue of, like, if I wanted to confirm why are we saying, okay, let me just say where we want f of x to be greater or equal to g of x. You can use inequalities. So this will be 2 over x minus 1 greater or equals to x minus, oh, there's a +1 here. So we can move like our expression this side, this will be 2 over x minus 1 greater or equals to, transpose, this will be x minus 2. But there's one trick you need to understand about inequalities. You cannot cross multiply. What do you have to do? You have to transpose this to the left-hand side. This will be 2 over x minus 1 minus into x minus 2 greater than 0. We do not cross multiply. Or you can just, yeah, it's okay. We can just, like, we can also take it that other side. So it's over 1. Let's simplify with it. So this will give us x minus 1. We cross multiply. It will be 2 minus into x minus 2 together with x minus 1 greater or equals to 0. So this will give us 2 minus into, let's remove brackets, x squared minus x minus 2x plus 2 divided by x minus 1. This is greater or equals to 0. Then now you're going to have 2 minus x squared minus x minus 2, it's minus 3 plus 3x minus 2 divided by x minus 1 greater or equals to 0. Then we'll write this. This will be minus x squared plus 3x because it will be true that other side to x minus 1. Then let's multiply the numerator by negative. It will have x squared minus 3x over x minus 1. Since you multiply by negative, the sign will actually change. So what is the common factor? It's x into x minus 3 divided by x minus 1 less than or equals to 0. But no, any number divided by 0 should be undefined. So it means x must not be equals to 1. We restrict the denominator only. Then we have to determine the critical values. Critical values will be x equals to 0. Solving for x will be 0. X will be equals to 1 and x equals to 3. We still write this, but at the end we must restrict this. So which number comes first on the number line? We have 0 followed by 1 and followed by 3. So give me any number bigger than 3. It's 4. Let's substitute where there is x. 4 is positive. 4 minus 3 is positive. 4 minus 1 is positive. So positive divided by positive is positive here. And it's positive, it means this is negative, positive and negative. Now we are controlled by an inequality. Inequality says less than 0. So it means the answer should be where there is a negative, it's here and here. You see where there's a negative, it's any value that is less than or equals to 0. or is between 1 and 3. But since we said x must not be equals to 1, we exclude this value here. That's why we said, oh, we include the 0 here because there was no restriction. So that's why we said x should be less or equals to 0, or x should be, oh, sorry guys, we're not supposed to exclude this. We include at 3, not at 1. At 1, we are not including anything because we restricted the domain. Right. You see, we still got the same answer. It's the same answer. Because if you can check there, it says, what did we say about the answer? We said the answer should be between, yes, the answer should be between, that is, should be between 0 and, should be x is less than 0 or, no, x should be less than 0 or x between 1 and 1. So the answer still be the same. So what is the second one? The second one, we want where f of x times g of x, it's less than or equals to 0. So we can still do it like that. So we want where f of x times g of x to be less than 0. So let's do it algebraically. So f of x times g of x to be less than or equals to x. What is f of x? 2 over x minus 1 plus 1. What is g of x? It's x minus 1 less than 0. So we can first simplify this fraction. It's going to be 2 plus x minus 1 over x minus 1. Then we multiply here by x minus 1 less or equals to 0. Then we're going to have the numerator will give us x plus 1 over x minus 1 multiply with x minus 1, this over 1 less than 0. So let's multiply the numerator. This will be x plus 1 with x minus 1 divided by x minus 1 less or equals to 0. So you see that we only have this, so we're going to remain with x plus 1 less or equals to 0. So which means the x should be less or equals to negative 1. So you see x is less or equals to negative 1. So let's confirm the answer. So remember I said x should be less or equals to negative 1. So you can still, but however, when you are dealing with inequalities for fractions, you do not cross multiply. If it's a fraction, it means you must continue with that fraction. Take decision based on a fraction. It's very important. Right, let's go back. So what do we say? We said the x should be less or equals to 0. Or from negative infinity to, what is the, or where, I think there's a typo here. Let's confirm this. What do we want? We want where, what was the question? Okay, let's check something. Or where f, or one is above and one is below, one is above, one is below. One is above and one is below. Yes, 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 yes. This is actually wrong. I said less than, so it should be less or equals to, less than one, or less or equals to one, -1 actually here. Because we want to where one is above and one is below. Yeah, let's just make corrections. One is above and one is below. Okay, just wait. Yes, this is the point. I said less than 0, and at 0 it's here. No, it's wrong because at 0, like both are below, so it's from -1 going there. Any number less than -1, yes. So it means from -1, not 0. Let's just make corrections here. That's why when I'm working it algebraically, I'm getting -1. So it's just a typo here, guys. Guys, apology. Let's correct this. And even this. Right, should be any number less than or equals to -1. Yes. Any number less than or equals to -1, or from -infinity to -1, inclusive. Yes. 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 Then now, how about the f of x times g of g prime x? The f of x times g prime x, we can still do it. Even the other one where we said f of x over g of x is greater than 0. So just to confirm, f of x divided by g of x is greater than 0. What is f of x? 2 over x minus 1 plus 1 by dividing this with x minus 1. So we have to simplify the fraction. This will be 2 plus x minus 1 divided by x minus 1 divided by, here it's x minus 1 greater or equals to 0. So this will be x plus 1 divided by x minus 1 dividing here by x minus 1. We have to change division to multiplication here. So this will be x plus 1 divided by x minus 1 times 1 over x minus 1. Then it's greater or equals to 0. So let's work this out. This will be x plus 1 divided by x minus 1 squared greater than 0. But remember, x should not be equals to 1, because if you put 1 at the denominator, the expression will be undefined. So, but let's now get the critical values. It will be -1 or -1. We even include it. So we draw the number line, is -1 and 1. Give me a number bigger than 1, it's 2. When you plug at the numerator, 2 plus 1 is positive. 2 is positive, so it's going to be positive, negative, and positive. But since the unequal sign says greater than, we look where there's positive, but you must not include 1. So it will be any number less than or equals to -1, or any number greater than 1. Any number less than or equals to -1. Actually, why is it saying x plus 1 over x minus 1 divided by x minus 1? We change it to division. Okay, let's do this. Any number bigger than 1, this will be 2 positive, 2 positive. Between -1 and 1, let's use 0, 0. It will be positive, 0, positive. It will be positive here. Okay, now I see it -1. Any number less than -1, let's use -2. -2 plus 1 will be negative. And this one will be, so this is negative. Yes, I see it. It's negative. So it means the answer would be from, it's just that I did not confirm. The answer would be from minus 1. Okay, the answer will be from 1 inclusive up until 1, or n number bigger than 1. So that means we can just say from 1 up until, okay, so we can just say from minus 1 up until infinity, but x should not be equals to 1. Yes, from minus 1 to 1, or any number bigger than 1. Yes, yes, no, excluding 1, which is what we actually got. From minus 1 up until 1, or any number. So it's just that I do not confirm the answers here. Okay? Right. Then the other one, for the gradient, you can also do it algebraically. Just to confirm, but there is no need. You can read from the graph. Okay, what do you want here? We want the value of x, where was it? Yes, where f of x times g prime x, it's less or equals to 0. And what is our f of x? Our f of x is 2 over x minus 1 plus 1. G prime x means we differentiate the g. What is g prime x? This will be 1, so it will just be 1. So let's simplify this. This will be 2 plus x minus 1 all over x minus 1 is less than 0. So this becomes x plus 1 over x minus 1 is less than 0. But as a restriction, x must not be equals to 1. We restrict the denominator, but in terms of critical values, we write them. So it's x equals to minus 1 or x equals to 1. Which one comes first? It's a minus 1 followed by 1. Give me any number bigger than 1. It's 2. 2 plus 1 is positive. 2 minus 1 is positive. It's positive. Give me a number between minus 1 and 1. It's 0. 0 plus 1 is positive. 0 minus 1 is negative. This will give us negative. Any number less than minus 1 is minus 2. Minus 2 plus 1 is minus. Minus 2 minus 1 is minus. This will be positive. But we want where the answer is negative because of less than. So it means the answer is between minus 1 and 1. But we only exclude 1, but we include minus 1. You can also say it's from minus 1 to 1 exclusive. So this is what the answer is saying, from minus 1 to 1. So I strongly believe you are following. Let's just confirm if the answer was correct. But I strongly believe that that is the correct answer. Strongly believe that that is the correct answer. Right, let's go back to our workings. Okay, before we go back to the working, guys, let me erase something. Yeah, I want to first erase this. Okay. Okay. Yes, you see, it says from minus 1 to 1. 1.13 from minus 1 to 1. Yeah, so it's the correct answer. Right, then now let's now move on to the next question. I think with this one, I will only do the first two. Okay, actually the first one, because it says if you are given f of x, and this f of x is y equals to x plus 2, Okay, let me write it here. If f of x is equals to x plus 2 divided by x minus 3, then the question says rewrite the equation of f in the form of, so it means we have to write that to be a hyperbola. Let me show you how to do that. Right, to rewrite this, we have to say, okay, fine. We have, okay, let me just write it here. This is 2.1. It's x plus 2 over x minus 3. Okay, let me write it here. So it says, let me just use this one. If we have x plus 2 divided by x minus 3, number one, we look at the denominator. This denominator, we need to ensure that we rewrite this denominator at the numerator. And how do you do that? Look. I'm going to do this. I'm going to say we have y equals to, since we have x, I want to have this minus x at the numerator. So I'll just say x because I want to, so it will just be minus 3. Then after doing x minus 3, I also add by 3. Why? Because I want to have this at the numerator. I'm adding by 3 so that the expression, as if it's 0, then from there, edit this by 2 and divide here by x minus 3. So whatever is the denominator, I want to repeat it to be at the numerator. So it means this would be the ones that I wanted it to be. So I'm going to put it inside the brackets. X plus 3, then I add these 2. What is plus 3 plus 2? This will be plus 5 divided by x minus 3. Then from here, I can start with this and say 5 divided by x minus 3 plus x minus 3 divided by x minus 3. So this expression would be 5 divided by x minus 3. And this one will divide, then will remain with 1. Let me do another example. Imagine we have y equals to x plus 7 over x plus 2. So what I want to do is I want to have this x plus 2 at the numerator. So what I do, I'll just say y equals to x plus 2. I want this, but since there's a plus 2, I have to also say minus 2, as if it's 0, because plus 2 minus 2 is 0. Then I add whatever I had there, plus 7 over x plus 2. Why? Plus 2 minus 2 is 0. But now I'm going to group the x plus 2. Then now minus 2 plus 7, this gives me 5 divided by x plus 2. So from here, I can divide and say 5 divided by x plus 2 with x plus 2 divided by x plus 2. So this will give me 5 divided by x plus 2 plus 1. But there are many ways to skin a cat. There are many ways to skin a cat. Another way to do this, we can use, okay, let me just use, okay, let me write this equation. Okay, I will, okay, let me erase this because I want this to be permanent. I want to repeat it again. What is our equation? It's x plus 2. It's x plus 2 over x minus 2. So let me write it here. Let me call this 2.1. So it means I have y equals to x plus 2 over x minus 3. So what I want to do is I want this denominator to be at the numerator. So it means this will be y equals to x minus 3. But since I want this to be 0, it means I have to add by 3 and also add the 2. I believe you're following why I'm doing this. Then divide by x minus 3. Then you are going to first, then again we have to group the x minus 3 because it's what I'm looking for together. So grouping that, it means this will be x minus 3 grouped. Then I add the other one, 3 plus 2, which is 5, divided by x minus 3. And I can now divide this and say x minus 3 divided by x minus 3 plus 5 divided by x minus 3. So the x minus 3 and will divide, then I rewrite this. This will be y equals to 5 over x minus 3 plus 1. So it means this is the equation. Now we've written it in a standard form. So it means the rest you can do. But now the question is one. What if the equation is not like this? Maybe the numerator is 2x. Remember I said, like, as an example, I said, we can still work this out even if the numerator is. Okay, let's say we have something like this as an example. Let's say the same one, but there are many ways to skin it. We can even use cubic function. Remember, we can do this. We can say, since we have ax cubic plus bx squared plus cx plus d. If we wanted to change this equation, remember this is x plus 3 over, x minus 2, not x plus 3. X plus 2, actually, it was x plus 2 divided by x minus 3. So let me just write x plus 2 divided by x minus 3. If I want to use that, I can say this is my divisor. So I wanted to know how many times does it go into so it means this is my dividend. Right, then now I can say, let me write this x plus 2 to be in a cubic function. This will be 0 x cubic because we do not have x cubic there. And the 0x squared is not there. Then the c is there, is the x. And the d is there. Which means this is the same as x plus 2. I believe you're following, because this expression is what we have there. So I do not have cubic and squared. I only have c and d. So what I'll do is I'll just use division, long division, like synthetic division method, to say I want a, b, c, and d. What is my a? 0. It's not there. It's not there. My b is also 0. My c is 1. My d is 2. Then I'll have plus, 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 plus. The first number we always put 0. So what is my divisor? My divisor is x minus 3. So let's solve for x. So this will be 3. So if I put 3 here, I'm going to multiply. So let's start. 0 plus 0 is 0. So we put 0 here. 0 times 3 is 0. 0 plus 0 is 0. 0 times 3 is 0. 1 plus 0 is 1. 1 times 3 is 3. Then we add this. This gives us 5. So it means this is the remainder. And since this is the remainder, then I will say from y equals to x plus 2 divided by x minus 3. Listen to me very well. X minus 3 goes how many times into x plus 2? It goes once. It goes once. And what is the remainder? The remainder is 5 over x minus 3. So which means now the equation is 5 over x minus 3 plus 1. That is another example that one can look at. Let me do another one. Let's call this example 2. With example 2, imagine we had, like what I said, x minus 7 divided by x plus 3. Right, now we can use the first method. I want the denominator to be at the numerator, so it means this will be x plus 3. But since I want to be 0 plus 3 minus 3, then I include minus 7 divided by x plus 3, because plus 3 minus 3 is 0. So now I have to group the one I want. It's x plus 3 is what I want. What is minus 3 minus 7 is minus 10 divided by x plus 3. Let's do the division. X plus 3 divided by x plus 3 minus 10 divided by x plus 3. Let's rewrite this. This would be 1. So you're going to have minus 10 divided by x plus 3 plus 1. There are many ways to skin a cat. But now, imagine when we have this. This time around we have this. Y equals to 2x plus 7 over x minus 3. Y equals to 2x plus 7 over x minus 3. So it means we're going to write this twice. If we wanted to use this approach, this would be x plus 7 divided by x minus 3. Then we'll have to say this is x minus 3 plus 3, then plus x plus 7 divided by x minus 3. Then regroup this will be x minus 3 plus the other part will be x plus 10, then divide by x minus 3. And this will give us x minus 3 divided by x minus 3 plus x plus 10 divided by x minus 3. So this will divide, then this will give us y equals to 1 plus x plus 10 over x minus 3. Then we redo this again. This will be y equals to 2 plus x minus 3 plus 3, because I want it to be 0, plus 10 divided by x minus 3. So this will give us y equals to, why am I writing 2 here? So it's 1. So this will be 1 plus x minus 3 over x minus 3, then plus 13 over x minus 3. And what is this? This will give us y equals to 1 plus, this becomes 1 plus 13 over x minus 3. Then which will just give us 2 plus 13 over x minus 3. And what is the final answer? The final answer is y equals to 13 over x minus 3 plus 2. So imagine, like, look what we have done here. So it means if we do not want to do this, let's just call this let's just call this example one, example two. So with the same example, okay, let's example three. Example three. What if I do not want to use this? I will do this also. Okay. If I want to do this, I will just say or. We use long division method, synthetic division, I mean to say. It's 2x plus what? Plus 7 divided by x minus 3. Let's now continue with the next question. No. Okay. The workings, but it's not giving me options. Okay, let me just go back and try to do it somewhere here. Let me try to do it somewhere. We have y equals to 2x plus 7 over x minus 3. So this is our device. So I will say 2x plus 7 is the same as 0x cubic. There's no cubic here. 0b squared. It's only cx, which is 2x and d. So it means what I would do, I'll just put my long division there. Synthetic, then it's the a, the b, the c, and the d. What is the a? The a is 0, the b is 0. Actually, let me change this. Yes, the b is 0, the c is 2, and the d is 7. So it's a plus, 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 plus. We look at our device is x equals to 3, so I put it here. And this side is times, let's add 0 plus, or we have to put 0, 0 plus 0 is 0. 0 times 3 is 0. 0 plus 0 is 0. 0 times 3, it's 3. 3 plus 2 plus 3 is 5. Then 5 plus times 6, it's 15. Did I miss something? Then 15 plus, this becomes 12. 22 gives us 22. Okay, let me check if I've copied the equation correctly. X minus 3 plus 3 plus x plus 7. X minus 3 plus x plus 10 divided by, so this is 1 plus x plus 2. Okay, fine. 1 plus into x minus 3 plus 3, which will be 13. So if we multiply this back, would it give us the answer? Let's check. 18 plus 2x minus 6. Yes, it will give us x minus 3. So yes, to give us, it was, okay, 2x plus 7 by x minus 3. Let me check something. Two x plus 7, 0, ax cubic, bx squared plus cx plus d. Okay, 0, 0, c is 2, d is 7. We use 3, 0 plus 0 is 0. 0 times 0 is 0. 0 plus 0 is 0. 0 times 3, yes, 0 times 3, it's 0. Yes, that's my mistake. I can see that something is wrong here. This is wrong here. And even this is wrong because now I can see that something is not good. Okay, then now because 0 plus 0 is 0, 0 times 3 is 0, 0 times plus 0 is 0, 0 times 3 is 0, 0 plus 2 is 2, 2 times 3 is 6. And what is 6 plus 7 is 13. 13 is the remainder. So we'll say if we have y equals to 2x plus 7 over x minus 3. How many times does x minus 3 goes into? It goes twice. And it leaves a remainder of 13 over x minus 3. Yes, yes. Yes, yes. Okay, okay. So these are the answers, ladies and gentlemen. So you know that since we got this first one, it's 5 over x minus 1. It's 5 over x minus 3. So this gives us 5. Equation is y equals to 5 over x minus 3 plus 1. Then you can be able to answer the questions that follows. Okay, no, something's wrong. So plus 1 plus 1. Then already by getting this, you can be able to answer the questions that follows. So it's this plus 1. Then obvious asymptote, you can get the line of symmetry, then the range, domain, you can answer this on your own. Yes, okay, guys. I think I'll stop here. Kindly don't forget to like, subscribe. Yes, thank you.